Perfect. All right, so this is our third webinar in the Ensuring Quality Heat Pump Installation series. So today we're going to be looking at commissioning and performance verification of a heat pump installation. We're just going to start with a quick territory acknowledgement, and then I'll dive right into who we are as Community Energy Association, and we'll go from there. So just the next slide there, please, Rob. Perfect. And the one just after that. All right, so the Community Energy Association, we acknowledge that we carry out our work on the traditional and ancestral territories of Indigenous peoples. So through our commitment to truth and reconciliation, we support First Nations, Inuit, and Métis communities in taking climate action and reaching their goals of energy sovereignty, security, and resilience. So I'd like to begin our session today by acknowledging the Indigenous people from all of the diverse and beautiful places we are joining from. I know we have folks from across the province. So I'm joining from what is now called Nelson, but for thousands of years has been the traditional homeland of the Sinixt Nation, the Silks Nation, and the Ktunaxa Nation, and is home to the Métis and many diverse Indigenous peoples. So I just like to acknowledge with deep respect and gratitude that it is in thanks to their generations of stewardship that we're able to enjoy these mountains, forests, and waters in the way that we do. Just the following slide there, please, Rob. So who are we? CEA is a registered charity and nonprofit. We're committed to accelerating bold action by local governments and Indigenous communities related to climate and energy. So we have an unwavering commitment to our clients to provide services and support on the journey from awareness to plans through to implementation. So what does that have to do with kind of training and learning opportunities around high performance building? Well, in BC, buildings are the third highest emitters of greenhouse gas emissions. So to us, building better is a climate action. Just the next slide there, please, Rob. So today's webinar, this is an initiative through the Kootenay Clean Energy Transition. The Kootenay Clean Energy Transition, or KCET, is a project that was delivered to address shifts happening in the energy efficiency, renewable energy, and home comfort space. So through KCET, we want to help Kootenay and boundary communities prepare for a more energy efficient and healthy future through training and capacity building sessions like this one. So thanks to the generous support of the organizations you see listed at the bottom of the slide, we're offering this free workshop as part of that piece. So to see a full list of upcoming workshops and webinars, make sure to visit our website, our webpage at communityenergy.ca/built-environment. And then just the next slide there, please, Rob. Just for those of you on the call who are currently working on retrofits, on home energy retrofits, I just wanted to introduce the Home Performance Contractors Network. So if you're doing heat pump installs, window and door retrofits, or insulation upgrades, and your clients are wanting to access provincial and utility rebates, this is the network for you to join. Becoming a member involves industry-specific training, and then upon completion of the training, you receive training subsidies and costs back for the courses you've taken. So if you have any questions about how to join this network, you can reach out to Brady Sturgeon. Her email's just on the slide there. Now, one last slide before I introduce Rob. I'm just going to go over a few housekeeping items. So CEA, we are committed to providing educational opportunities to everyone regarding of your existing knowledge or experience. So it's really important to us that we provide a safe and open space for attendees to engage and participate. So this slide is an overview of some guidelines we'd like folks to adhere to over the next 90 minutes or so. So most importantly, just please respect our speaker, Rob, and each other, and allow attendees on the call to ask the questions that they have. And folks, please feel free to ask any questions that you have. Today's session is geared towards all building professionals. So we recognize that everyone's kind of coming in with different levels of knowledge. Just a few other things. So we have added on an extra 30 minutes to today's presentation just to allow for some more questions and answers. So the first hour is still dedicated to Rob's presentation, with that last half hour for the Q&A. So if you have questions that are directly related to the specific content of Rob's presentation, please feel free to unmute yourself and ask Rob directly. However, if your question is more specific or technical, please save it for the Q&A portion. Some folks may have to jump off after the first hour, so I want to make sure we respect their time and have a chance to go through the entire presentation within that first 60 minutes. And as you would have noticed, as you logged in, we are recording the session. It will be posted on our CEA Built Environment webpage and shared out with all of you folks on this call, along with the presentation slides. All right, so that's it for me. It's with great pleasure that I introduce Rob Pope, Senior Consultant with Ecolighten Energy Solutions. We're really lucky to have Rob here with us today. He has vast knowledge and experience in the HVAC industry, and he's been involved with installing and servicing energy efficient systems basically since day one. So huge thanks to you, Rob, for joining us today, and I'll pass things right along to you.
Thanks, Jenna, and thanks for everybody. Thanks everybody for your patience waiting for the technical difficulties. That was at my end, by the way. Um, so let's get started. Today's agenda, we're going to talk about commissioning in general, but in process, what part of the installation process it is within, what performance targets are, because after all, that's what we are checking when we're commissioning a system. Testing function and performance of a newly installed system, control systems, manufacturer startup and warranties, maintenance requirements and schedules, documentation, and finally homeowner education. So the process, every installation has various stages, and these are them. Stage one, discovery, then load calculations, equipment selection, HVAC design, installation, quality insurance, performance and verification, and homeowner education. Commissioning falls in this stage here. If we take that stage out, then we have an incomplete process. And that is the stage, unfortunately, that gets has the least amount of full attention in any installation. So performance verification, proper equipment selection, quality workmanship are 2/3 of a successful installation. I kind of think about it like a 3-act play. You really do need that final act, otherwise you're left hanging. And it is literally about 1/3 of the process. You know, it really matters a lot. It's, as I said before, it's often overlooked. Um, Typically what happens, worst case scenario, and you know, it's not all the time, don't get me wrong, it's not dire straits out there, but too often what happens is the installation is completed, you fire it up, you turn it on, if it's summer, you put it into cooling mode, you check out the registers with your hand. Okay, air's coming out, is cool, is it achieving the set points? Okay, great, pack up, clean up, and leave, right? That a variation of that happens far too often when there's a lot of things, as we'll see later on, that you really need to do. One of the things that's happening, among others, is that you're checking the performance targets. So we'll talk a little bit what are performance targets. But before I do that, um, the role in commissioning is, in an ideal situation, you have one person designing or one entity designing, another person installing, executing that design. And in that case, it's the installer's responsibility to commission the equipment, to do all the checks, do all the startup tests and so on, for not just checking performance, making sure that the system has a good shakedown. If there's any issues with components that need to go back to the supplier for warranty, you want to get it over with now before you hand it over to the homeowner. So it's the installer's job to do all that testing. And in the case where you have a separate entity doing the design of the installation, it's their job to make sure it's done and take the data that's collected from the commissioning process and just ensure that it has hit the performance targets. In a lot of cases, and this is for BC for the next little while, most cases in the province, the installer is the designer. And in that case, they have both roles. So if we go through the whole process to the commissioning, which is stage 6, and we started with the discovery, what have we learned? Well, if we start with the discovery, we'll have learned and we'll know what the homeowner's expectations are for performance targets relating to comfort settings, for example. What is comfortable for them? What requirements for indoor air quality are they expecting? Sound, of course, everybody wants it to be quiet. And what kind of controls? Some people want, a lot of new gadgets, and some people want it nice and simple, up and down. So we'll know all that. In this load calculations, stage 2, we'll know the heat loss and heat gain for each room and performance targets for the climate data. That means that we'll know what temperature it's based on for outside conditions in the winter and in the summer, and what the indoor conditions are. What is comfortable to the homeowners? What are we designing for? We'll know the energy BTUs required for the total house and each room. We'll know the infiltration rate, basically how leaky the house is, how much air is going through the envelope. And we'll also know all the assembly thermal details. Stage 3, equipment selection. We'll know the technology, brand, and models of the selected equipment, and the performance targets for airflow, fan performance for volumes of CFM at selected pressure drops, capacity and efficiency at various outdoor conditions, the balance point, which is the point at which the auxiliary heat is required to come on because the heat pump can't keep up. If you have auxiliary heat, you don't always have to have it, but in most cases you do. And you also know the control systems. And this is a separate entity in the process because there's a lot to the equipment selection because it's based on the load calculations, and you got to look up the fan curves, performance curves, and all that stuff. And you got to do a balance point calculation, and that's what you see on the right there, an example of a balance point calculation. So that's part of the process and establishes some of the performance targets that we'll be checking down the road. The design. Once we've done the first 3 stages, then we have enough information to inform us and guide us when we do our layout of the design. New construction, you know, there's a lot more involved than a retrofit. In a retrofit, there's at least in this part of the process, it's not a full-on design, but it is a plan. It's plan what you're going to take out, what you're going to change, what improvements you're going to make and to the existing system, where things are going to live. You know, where's that outdoor unit going to be? All that kind of stuff. Either way, there's a design of some kind, simple or complex. There's a design, and that'll inform us about the equipment placement, duct piping, sizing, and routing, terminations, in other words, grills, registers, and each one of those terminations where we're supplying air through a grill or returning air through a grill should have airflow targets. So we'll know what those airflow targets are. How many CFM are we delivering to each of those grills, for example? We'll know thermostat locations. And in a full-on design for new construction, there'll be a section for standards of practice, which gauge of pipe to use, what insulation to use, how to seal it, and that kind of stuff. And then the installation, executing that design and everything that came before it. If everything goes right, you know, and we've done our quality assurance, the installation has been done, we'll know that it was done to meet the design intent at an acceptable standard of practice. So all up until this point is good, let's say. But what we don't know is, did it all work? You know, it's good enough to come up with a beautiful design, do all the load calculations and everything else. But what's really important is whether or not it worked, right? And this is what commissioning is all about. Excuse me. Are we delivering the quantity, velocity, and temperature of air we designed at each grill? Is the system responding to heating and cooling calls? Is the system achieving the thermostat set points within a reasonable time? These are things we're checking, remember. Are the systems switching to auxiliary supplemental heat at the calculated balance point, you know, when we need it, not before we need it? Is the system balanced, especially the HRV, if there's an HRV involved? And of course, you know, is it all quiet enough? Are there noises that shouldn't be there? You know, like airflow sounds. You know, if we got blocked registers or pipes or something, we have air screaming out of a single grill, what's going on there. Um, Rattling, anything outside of what we would expect. But what I've just been talking about is really performance, right? And performance is like what you see on the stage. That's the performance. Is it delivering the comfort that we were expecting to deliver, that we wanted to deliver, you know? Um, but behind the curtain, we have function, and that's all the technical stuff that makes that all work in front of the curtain, right? And it's more technical, and it's something that you really need the proper tools and gauges and so on to test. And of course, you need to have the know-how to do it. So utilizing appropriate tools and devices to measure airflow. So you're going around with an anemometer, for example, and looking at what CFM, velocity and temperature the air is coming out of each of those registers. You're measuring refrigerant charge, making sure there's no leaks, making sure there's enough refrigerant as per your manufacturer's requirements. Temperature, you're measuring temperature of a number of things. Temperature rise between the return and supply air, for example, and temperature in the rooms, the ambient temperature, outdoor temperature, part of all of this is calibrating the sensors. You're checking pressures, the total external static pressure of the system. That's basically um, is the air being delivered through a ducting system that is sized adequately, that it doesn't squeeze and pressurize the air and restrict its flow. That's a pressure. We're also, if we have a dual fuel system, we're going to want to measure the gas pressure, the inlet pressure on the furnace. And we want electrical measuring equipment to see if we're drawing the right amount of amps from the compressor, for example, a motor. We have enough, the right amperage, ohms, and voltage going everywhere it needs to go. We also want to make sure there's no defective components from the factory. There's oftentimes, you open up a box of something, it could be anything that's part of the system, and something's not working. You want it, if that happens, it doesn't happen all the time, but it's often enough that something you got to look for. And when it does happen, it's a warranty issue. You take it back to the supplier right away, get it replaced. You want that done now, not after the homeowner's been living there for a little while and then it goes wrong late on a Sunday night in the middle of winter. And you want to make whatever adjustments are required to the system's default settings from the factory to customize it to the installation that you're working on. As you can imagine, from the factory, there's a lot of configurations. Fan speed is one good example. It just goes out with a default set of settings. But we might want to select a different fan speed. So we would configure the system in this particular case to a different fan speed. That is adjusting from the factory default settings. And there's other cases like that. So that's the technical part, the functioning part behind the curtain that needs to happen. And as I think as you can see from this already so far, there's a bit to it. So you can't just turn the system on, feel with your hand to see if there's air coming out, and then leave. There's a lot more to it. I want to talk about control systems because that's a pretty difficult and fastly evolving area in this industry. And this is where we have the hardest time with capacity with technicians keeping up with the technology. There's so many technologies out there, and as I said, they're evolving quickly. So what you see here is a very, very simple setup. This is probably your average retrofit situation. You have a thermostat. Thermostat has within it a sensor sensing temperature, and the temperature drops in its heating season, and the thermostat says, okay, just lost 2 degrees or 3 degrees, whatever it is, bring on the heat, and it connects to the air handler, or in a dual fuel system, the furnace, which will have the refrigerant coil attached to it, and it'll can be connected to the heat pump. All of this comes on, brings on heat till the thermostat's satisfied. But when it gets more complicated is when you start adding things. So let's imagine, for example, we add a electronic air cleaner. Now we have to tie that into the control system. If we add in electric auxiliary heat, we have to add that into the control system. And it keeps going. Let's add an HRV in there. What about a humidifier? Um, what about control or a zone system in the controls that go with it? What if we want remote connectivity? It goes on. There's a lot of things to connect. All these components have to talk to each other. They have to act together, right? And so it gets a little more and a little more and a little more complicated each time. It's not rocket science, but it just needs diligence to be done properly. Now, if we add a radiant system, as you can see, it starts to get pretty crowded in that, the control room there. Now we're going air to water heat pump, probably. We're adding a buffer tank, some pumps, some radiant manifolds, more radiant thermostats, radiant controls, and so on. As you can see, it can get complicated. So just the controls alone, making sure all the wiring is done to all the components properly, and each one of those components are configured to talk to each other. They have to have a handshake with each other, and they have to know each other exists. There's a little more to it than most people realize. It's a web. Manufacturer, startup, and warranty. Oh, before I go on any further, you guys are welcome to interrupt me anytime if you have a question or a comment. You can just unmute yourself if you want.
There was a question that came through the chat, Rob, that I think is
Sure.
relevant that we could address now. Troy just asked, would the manufacturer provide a functional checklist for commissioning their system, or do you create your own? I have seen functional checklists used as standard, but not applicable to other systems.
Great question. And we're going to cover this actually. So I'm happy that question was asked. So these next few slides will actually answer that question. So I'll just continue if that's okay. As you can imagine, equipment manufacturers, suppliers, the supply chain of the equipment, generally speaking, doesn't like it when a technician shows up with a compressor or a fan or something and says, hey, it doesn't work, I need a replacement. Those nuisance warranty claims that come up. It's okay if the component is actually defective, but in a lot of cases, it's pilot error. It was installed incorrectly, wasn't commissioned properly. Those are the nuisance issues that manufacturers don't want to happen. Nobody wants that to happen. And so as a consequence, they have startup checklists, and they have warranties that are tied to those startup checklists. And those startup checklists are not full commissioning because the manufacturers don't know what all the performance targets are of the job. They just want to make sure the refrigerant flows are correct and the amperage draws are correct, and all the things that make their equipment work is done. And so here's an example. All the manufacturers have them, these commissioning checklists. So these are in every manual for every major piece of equipment. It is, and I'll emphasize over and over again, it really, really is important that all this paperwork is done, that each of these parts of the commissioning, and this is only one part of it, is followed, filled out, and recorded. So this is the startup checklists. There is a commissioning checklist from the industry, and this is where we see the discrepancies, right? Because as I said, the manufacturers are only concerned about their equipment operating adequately to ensure that there's no failures in major components like fans, compressors, and so forth. It's installed to a standard that um, is contained within the equipment itself. If the equipment is functioning, they don't know what the heat load is of the house that equipment is living in. They don't know the performance expectations and all that kind of stuff. So they're focused on their equipment, and that's where the discrepancy exists. Then there are outside and around um, those kinds of startup checklists, commissioning reports from industry associations and from major industry associations like here in BC. TECA is one across the country. HRAI is another. There's the Home Performance Stakeholder Council is another. And they would be typically include functional tests for external static pressure, airflow, controls, refrigerant charge, and temperatures. Here's an example of one. If you have a dual fuel system, for example, um, this is a checklist from TECA. Um, this is a BC organization, and what some of the things, not all of them, but some of the things that you'd be checking for is the inlet gas pressure, manifold gas pressure, external static pressure, temperature rise, and clocking the meter. But there is a form out there for this, and TECA has one, HRAI has one, two industry organizations. Or you could get a generic one online, but I wouldn't recommend it. If it's a heat pump, there's a heat pump commissioning sheet from the Home Performance Stakeholder Council, and HRAI has one, TECA has one, and some of the things that would be on that form that you have to fill out is what's the refrigerant charge, airflow, power inputs, measuring, balancing temperature check of airflows, and verifying the integration of controls. It would be all on that form. If there's an HRV, sometimes it's pretty independent of everything else in terms of the balancing requirements, right? But HRVs are often integrated with forced air systems, so there is some overlap. In either case, there's a checklist for this or a balancing report. This happens to be HRAI. There's a TECA one as well. There's also most major manufacturers in this province will have a version of this of their own that is as complete as this, and then it's about the balancing of incoming and outbound airflow and the balancing at the exhaust points and delivery points. Here's an example of one of these checklists when it comes to the more technical stuff. They'll want to know things like your ambient outdoor air temperature, what motor you're testing in and all that kind of stuff. So, but look at this. There's a lot of technical stuff going on here that wants to be checked. And the point of all this is you don't need to know all these details unless you're a technician yourself and you want to know. What you need to know is that there's a lot more to it than most people realize. So you can't just, fire the thing up and be gone within 10, 15 minutes. There's hours literally of time that it takes to properly commission even the simplest system, a simple retrofit, for example. You can spend a day or two installing the system, depending on how easy or complex it is. But whatever system it is, in a simple retrofit even, you're going to spend a few hours, if you're doing it properly, commissioning the system and testing and checking everything. In maintenance, well, I'm going to talk about the documentation a little bit later, but in maintenance, what you want to do is extend the life cycle of your equipment as long as possible, right? It's just like a car or anything. You take good care of it, it'll pay you back in service, right? And some of the things that you have to deal with in maintenance, and we're talking here about preventative maintenance, is the simple things like filters, loaded filters, or coils, dirty coils, leaves and pine needles on the outdoor unit. These things impact the airflow of the system and decrease performance, so it's going to be less efficient and can damage and will ultimately damage components. It'll shorten the life cycle of the equipment for sure if they're not taken care of adequately. It's just like not changing the oil in your car. Some of this preventative maintenance can be performed by anybody from the homeowner if you know where the filter is, you know what size it is, you know where to get a replacement, and you remember to do it, right? And you clean off that outdoor unit, a couple times a year. Yeah, you can take care of those things. And it's important to take care of those things, but that's not all there is to it. It is really, I think, a good idea to have a maintenance contract, a maintenance and service contract, usually with the installing company, but sometimes a separate company just specializes in doing that because there are technical um, requirements to maintaining the performance and longevity of the equipment. Critical that the right HVAC technician with the right tools do the work. Right? You don't want somebody doesn't understand refrigerants and voltage and wiring. You don't want a service contract where all they're going to come and do is, do a bit of cleaning and change some filters for you. There's more to it, right? It's really important that um, they do these things. So, service technician once a year, ideally, twice a year if it's a complex system, and at the very least once every couple of years. You want to check for adequate airflow and external static pressure. You want to check for temperature rise between supply and return air, inlet gas pressure, and clock the meter on a dual fuel system. Inspect and clean the evaporator coil. Um, Check the refrigerant for leaks and top it up if there's any lost refrigerant. Inspect, clean, and tighten all the electrical connections. They can get loose. Any tiny little bit of vibration anywhere in the system could potentially affect the connection and the contact of a wire to a terminal that wasn't tight enough in the first place. So it's important to check all that, measuring the energy amperage draw on especially the compressor and the fan. Um, Check controls in all modes. You want to check it in heating mode, cooling mode, continuous fan mode, first and second stage if there's stages, zoning if there's zoning, and auxiliary emergency heat, among other things. And check, and if necessary, calibrate the sensors. You might discover where that thermostat is on a wall. In some cases, the sensor's built right in. In some cases, it might be impacted by something nearby. It's always, maybe a degree or two off, right? So you want to calibrate it, reset it. Um, if you find it, or the outdoor temperature sensor might be in a place that gets too much sunshine, so it's not sensing the ambient temperature where you need it in the shade, ideally. Or there might be something nearby, maybe a dryer vent too close by coming on and then impacting what it's sensing. Anything like that, you just want to make sure that the sensors are actually reading the right temperatures. Documentation. Um, Most of the time, and I go in and out of finished homes quite a bit. Most of the time, what I see is a manual. It usually has a footprint or two on it and a coffee stain in the corner of the mechanical room somewhere. You know, Sometimes you see them put into uh, a package where, hanging on a return air drop or something, or somewhere in the mech room. Very rarely do I see what I want to see and what you or the homeowner should expect to see. Every homeowner should expect this. You just spend a pile of money on this system. It's not a simple system. It's not a vacuum cleaner. It's a mechanical system. It is the difference between being warm when it's cold outside and cool when it's hot outside. It's the difference between indoor air quality and having poor indoor air quality. It's an important system, and it's an expensive system that, someone just spent a lot of money on. And so the expectation to me is very reasonable that this happens, that you have a nice binder tabbed with all these documents in it. The documents should include um, the energy audit modeling, load calculations. All right. It should include the documentation for equipment selection, which would be, submittals and um, the uh, um, the balancing um, calculations. It should also include the design and any as-built variations during construction that happened from the design that were accepted. So that, if down the road a technician trying to troubleshoot a problem wants to know where everything is behind those walls and ceilings, right? That should be in there in that set of documentation. It should include the installation manual. It should include user manuals. It should include these next few things. So warranties. All equipment has warranties and they all vary. There's some with more coverage, less coverage, more years, different conditions and exclusions and that kind of stuff. So it's important that that document is understood. Some of them you have to send in to activate the warranty period, um, and some you don't. But you should know all that stuff. So you need the warranty documents, and all manufacturers have a variation of a warranty of some sort. That's pretty important. That should be in the documentation as well. Manufacturer startup documents. Remember we talked about this? These are the things the manufacturer wants you to do to ensure that the equipment is functioning and as the manufacturer requires, and you install them as per the manufacturer's requirements. And all the manufacturers have these startup documents. Commissioning reports. Commissioning reports are more wholesome or more holistic than just a startup. And recognized associations like here in BC, TECA, across the country, HRAI, Home Performer Stakeholders Council, for example, all have them. And there's no shortage of them. I mean, they're not inaccessible. Any contractor can get a hold of these. And we should be able to see them in that binder that I was just talking about. Maintenance requirements and schedules. With maintenance in service, most contractors have their own templates that they use with their own logos and so on because they have their own contract conditions. Um, from a homeowner's point of view or somebody acting on behalf of the homeowner, builder, for example, you should see something like this, something that has a maintenance schedule. Um, how many filters, what size are those filters, how often do they need to be replaced, and with what kind of filters, where do you get them? If they're an obscure filter, well, where do you get them from? As opposed to something you can go to any hardware store like Home Depot, Review, whatever, and grab one off the shelf there. Um, and all, the whole um, routine for that preventative maintenance I was talking about, both from the easy to do stuff and the technical stuff. There should be something in the documentation about that. And finally, I know this commissioning is what the subject for this presentation is, but commissioning and the last step, which is the handing the system over to the homeowner, are kind of integral. And no installation is complete until we've done that. So while we're talking about it, I just want to make sure that it's understood all that commission is ultimately for the occupant's benefit, for the homeowner's benefit. It's really important, and I say it all the time. The homeowner ultimately is the most vulnerable person in the whole shooting match when it comes to this industry, right? And we have to protect that vulnerability by, going through the whole process, doing a good job all the way along, but then handing over the system to the homeowner so that they understand what it is that they have. You can point to that's the HRV. Here's how you open it. That's where the filters are. This is how you take the core out. You might need to do that once every so often. And there's the filter for the fan coil. By the way, this is how you program your thermostat and so on. Let them do a walkthrough, let them understand the system, and make sure that all that documentation is in front of them and they know what it is, what it means, what to refer to. If they're having a performance issue, something's going wrong, it's not heating up in the wintertime for some reason, they know who to call, and that person, whoever that technician is, comes in and they can look at the record, see what the condition was when it was commissioned, because that will ultimately help a lot in troubleshooting what the issue is currently. I know it's a lot to digest for a homeowner, and sometimes it's more than one go through, but it is really important because too often over the years, I've gone to emergency calls to deal with an issue that was simply nothing more than the homeowner didn't know you can't do this, or you have it programmed wrong, or it's not in heating mode. It's in cooling mode. Just some things like that. Or, look at the filter. It's loaded up. The fan can't get air past it, right? It's important to um, give the homeowner everything they need so that they can enjoy the system they just spent all that money on. And one of the or some of the key components is the HVAC operation in general, like I talked about, how this all works. That's outdoor units, that's the heat pump, those lines in between, that's carrying refrigerant, and so on. How to program the different modes that can be managed from the thermostat. There's heat, there's cool, there's auto, there's continuous fan, there's auxiliary and emergency. There's stages, first and second stage, and potentially zoning. There's a lot to it. So it's easy to understand how a homeowner can get confused. Location of filter sizes and how often they need to be cleaned or replaced. Preventative maintenance requirements from the technical point of view, and of course the warranties. And I believe that's it.
Ben asks, PNNL has released an open source commissioning tool called Quality Install Tool, and he linked the tool to the tool there in the chat. Does Canada have a similar project?
Not that I'm aware of. And to be honest, I'm not aware of the one that you're referring to either. It would be a good idea for sure if there is one, but there's not an online tool that I'm aware of like that. And if there is one in development, I might be out of the loop on it, but I'm not aware of one.
Yeah, if anyone on the call has seen one, please feel free to let us know about it. Larissa asks, what are the main points to consider in the commissioning sheet when it comes to dual fuel systems?
Well, I guess there's a couple of things. One is life safety, right? And that's because you've got a fossil fuel there, a volatile fossil fuel. You want to make sure in the commissioning that is correctly installed in meeting the requirements of the Gas Safety Act. So you do want to make sure that you're the obvious thing, no leaks, of course, right? But the amount of pressure being delivered through the gas line is not constant like people would um, instinctively imagine. It's not the exact same pressure. So you want to check what the pressure is and adjust it to the requirements of the furnace, for example, your dual fuel system. That's pretty important to check the pressure. Make sure you're not overwhelming or underwhelming that regulator with too much or too little pressure. It's got to be right within a little small margin. The other critical thing is with a dual fuel system is ensuring that um, your heat pump is doing most of the work it can, and that dual fuel is only coming on when you need to. Um, the There should be a balance point at some point in time. You don't want to be burning fossil fuel at a higher cost per unit of heat. So ideally, you would want to ensure that it's coming on only when the heat pump can't keep up, and not too soon before. It's amazing how often you see a heat pump installed as if it's just an air conditioner. It's not coming on at all, or it's coming on very little in the wintertime. The other thing, of course, is combustion. You want to ensure that products of combustion are going out and not coming into the living space. The dual fuel, you usually have a condensing furnace, with um, uh, one pipe, CPVC, for exhausting, and another pipe for bringing in the combustion air. One of the shortcuts that happens quite often, installers will not run that combustion air to outside. They'll use room air, house air for combustion. That is a mistake. The manufacturers say it's okay, but um, in the context of tight homes, energy efficiency, and those kinds of things, it's not okay. Yeah, that pipe has to also be vented to outside to bring in fresh air for combustion. Um, Other than that, yeah, I think that in a dual fuel system, those are the main points that I would um, be checking for, among other things. But those would be the big ticket items that I would be checking for in the commissioning.
Great, thank you. And Larissa, if you have any follow-up questions, feel free to let us know. And folks, I am just going through the questions that have popped up in the chat, but if you do want to ask Rob a question directly, just raise your hand and we'll make sure to call upon you. Okay, so this question kind of sparked a bit of conversation in the chat, but I'm going to read it out loud for those of you who are watching the recording and couldn't join us live today. So bear with me a little bit here. Ben just asks, he says, I've heard that many technicians find checklists cumbersome and confusing, either falsifying or neglecting commissioning checklists and forms altogether. Do provincial or municipal bodies audit HVAC businesses to confirm that they're accurately completing these checklists or follow a process to verify that the work is being done correctly? And Ryan just responded saying that our experience is that when commissioning sheets are required by programs for rebates or AHJs for compliance, the compliance review is on the completed fields and not on the integrity of the data presented. Additionally, a performance audit, i.e. recommissioning, is typically not done unless under a research project in Part 9 homes. Sorry, I have a cat.
I think
Sorry,
that would
Rob,
be a
I was
good
saving
idea.
you some words.
Yeah, thanks, Ryan. No, that was really good. I wouldn't mind, Ryan, if you would put that into context. Ryan and I work together. Um, um, we share the company. Ryan is the CEO, and we do an awful lot of follow-up and quality assurance for utilities and governments and so on. So we see a lot. We see an awful lot of what goes on. And I think it would be great if you don't mind, Brian, if you could share what you see sometimes with the same numbers appearing on all these
Yeah,
different jobs and that kind of stuff. It's
yeah,
quite
yeah,
shocking.
yeah. As Rob alluded to, commissioning is kind of a weak link in the process. And yeah, when we've seen it, kind of what I said there was the data integrity is the piece that's missing. So people who are looking for commissioning sheets are likely doing a review of, is the information presented when it's provided, not necessarily checking whether or not like it's the correct information or actually auditing the information. So as Rob alluded to, we've seen our experiences is contractors reusing the same performance data and just changing the address of the homes, or not even really having an understanding of what the metrics should look like, especially around things like external static pressure testing and others. You can see that they either don't have the gauges or they don't even know what inches water column is, or things like I'm yeah, I'm not trying to make light of it. I'm just saying Performance verification is super important, and it's a weakness within the industry. It's a one thing to ask for the data. It's another thing to verify and be confident with the data. And so there's a lot of work to be done to help contractors in this space. Ben,
Yeah.
you've asked a lot of really good questions, and so I'm not trying to call you out, and you're actually linking to a lot of interesting stuff that I was not aware of. Are you in the United States in this? Are you practicing there, or where are you?
No, I'm here in Canada, but my clients are technology companies who create software for residential HVAC. And they're mostly based out of the US. That's where the majority of their market is. Canada is not super far behind, but in some areas very far behind as far as the opportunity. So like the primary company I work with is MeasureQuick.
Oh yeah.
Who they have basically, it's a software app that connects to all the Bluetooth tools and then does all the commissioning with kind of like with all the real-time data from the probes, so that you don't really have to falsify. You can't falsify, and you don't have to deal with all the friction of trying to collect all these measurements, where if you're doing it manually, like if it takes you a couple minutes to go from inside to outside, then now because the measurements are different, that actually it changes the outcomes of all the other equations. So I'm very interested in kind of seeing some of that similar technology be applied to Canada to be able to take care of that data integrity side of it, because that one study from the DOE is a little troubling to see just how many systems are installed that like out of the gate, almost like the majority of systems installed have at least one fault.
Yeah,
We reference that in a few others as our Houston, we have a problem upfront statement in a lot of our presentations, because it's just you don't know what you don't know, and you know, the installed versus lab condition performance of equipment is a big issue.
Yeah, and that's why we're here, you know, and this is changing, luckily, that, you know, we're evolving now to where we're going to tool up the capacity of industry, especially on the authorities' jurisdiction, the have jurisdiction side, municipalities, given the resources and tools they need to verify all this kind of stuff. So luckily we're moving in the right direction now, finally. But I think from a homeowner's perspective or builder's perspective, that it's important to understand that you don't have to know all the technical details. You just at least expect a process to happen that's more involved. That, you know, if the person doing the final commissioning of the system doesn't show up with an anemometer, there's a problem, or they don't have refrigerant gauges, that's a problem, you know. But studies in the US and Canada across the country have shown that it's incredible, but it's the majority of cases, it doesn't happen, right? And that's where we need to focus our attention, is making sure that however good the installation is, however well the whole process went, if it's not commissioned, then it's just a coincidence if it works well. And, you know, it's too important a thing to rely on that.
I might steal that quote: if it's not commissioned, it's just a coincidence if it's working properly. It's amazing.
Sure.
Great.
Thank you. Thank you for
Ben,
answering.
okay, great. I was going to ask if you have kind of any follow-up on that topic before we shift to other questions.
I might want to connect with Ryan and Rob outside of the session, maybe.
Perfect.
Sure.
Perfect.
Happy to
We
chat.
found some fellow HVAC nerds. Perfect. All right, great. Thank you for that. Okay, let's see, back to these questions here. Okay, Billy asks, he says, many folks cannot afford to get their systems inspected annually. Is there a sense of what the most amount of time that a budget conscious homeowner can get away with when it comes to inspection or maintenance?
Well, that's a reality that we have to understand. And so of course, you know, having a full service done annually is ideal, is the best, even twice a year from the more complex systems. But if you can't, I think every 2 years at least, in between though, that puts the onus on the homeowner themselves to change the filters. That has to be done seasonally. That can't be left to the technician. It might not come for a year or two, right? That has to be done. And that is pretty straightforward if that handover in the first place is done correctly. It's just, there's the filter, this is how you pull it out, this is where you get your new filter, how's how you put it in, make sure the arrow's pointing the right way, you know, that kind of stuff. It's not that big of a deal. Keep the filters clean, and make sure that there's no buildup of materials. Leaves and pine needles is the most common issue around the outdoor unit. If you're taking care of it that way, then you probably get away with every couple of years. I wouldn't want to push it longer than that.
Great, thanks. Billy, if you have any follow-up questions, just let us know. Troy asks, should equipment be tagged and referenced on CX documentation, i.e. pump one, condenser one, etc.?
Oh, yes. Good question. Yeah. I like, you know what, the effort to tag things is not much compared to the benefit you get from it. You know, just to know simple things like whenever you have like a simple thing, an arrow, airflow this way, you know, that's your supplier, it's outgoing, your return air, you know. And yeah, of course, unit 1, unit 2, you know, everything tagged, and that tag correlating between what you see in the mech room, because that's where it should be tagged first, and what you see in the documentation, that they're correlated. It should be tagged. I think it should be treated with a lot more deference than it typically does nowadays. You know, it's important stuff. It really is. It's expensive. If something goes wrong, it costs a lot. And it usually does it at an incredibly inconvenient time. You know, so all that kind of stuff, tagging, I agree, should be done.
Wonderful, thanks. Thanks for the question, Troy. Kirsten says, as a designer, can I specify an outside audit? Does anyone do that? So anyone on the call, if you do that, let us know in the chat. Any comment from you there, Rob?
Well, when we design systems, we do the audit because we are selfishly protecting our own liability. That's not the only motivation, of course, right? We want to make sure it all works. I mean, the ideal situation, everybody walks away from a project happy, of course, right? Yeah, so the designer should be able to do their own audit and their own quality assurance and verification of whatever it is they designed, right? If you don't want to develop your design chops, be really good at designing and hand over to design somebody, you never know if it got executed or not. You need to follow up. If not, you can get an outside or third-party audit done. That is very common in commercial applications, Part 3 buildings. In that, you know, you get a third party coming and doing balancing of the system and all that stuff. But I think that what if you're a designer, you have to audit yourself. If you're a builder hiring a mechanical contractor, that's when you would want to ensure that there's going to be some sort of audit and verification, or whatever you want to call it, quality assurance of the system done by a third party. That would be worth investigating. And ultimately, what we would like is the authorities having jurisdiction to do some of that verification and auditing. And then that's coming. It already exists, for example, for electrical, for plumbing, for, you know, all kinds of components in the building, structural, other things. Ventilation, actually, there's a lot of third party or authorities with jurisdiction to require ventilation certificates to be signed by somebody certified and filled out and all that. Hopefully down the road we come to a point where the authorities have jurisdiction all have the resources and the tools to do the verification as well.
Great, thank you. And then our last question here in the chat, folks, if you have any other questions, feel free. We did just add on this half hour so that we had time to go through all the questions. So we'll take as long as it needs. So feel free to pop them in the chat. Troy just asks, what are your thoughts on endotherm for radiant heating systems?
On which?
Radiant heating systems.
My thoughts on radiant heating
Oh,
systems?
sorry, endotherm for
Endo-
radiant. Yeah.
Endotherm.
Troy, maybe you can let us know a little bit more about endotherm.
Yeah, endotherm is from PACE. It's a additive to closed loop radiant systems that actually increase the performance. So Fortis is actually promoting this now in all radiant systems. It's in the 1% additive. So it's expensive.
Okay, yeah, right.
But it's an additive that actually makes the efficient and the conductivity more efficient to the environment, to your mass.
Yeah, there's been a number of those. There's a number of them on the market right now, and there always has been products like that coming and going for as long as I can remember. We have never used anything like that. The question becomes, are we in diminishing returns or not, right? Like once we get all the oxygen out of the system, all the air out, we bleed it, it's running. The water eventually is dead. There's no oxygen in there. It's at its most conductive value, you know, and you've designed the system well enough and installed it well enough that you're getting the right amount of flows and velocities and everything else. In other words, if you've optimized the system as you should, then anything you add to it to gain a little more conductivity, you have to be able to answer the question. And this question is simple: is it worth it? What are you getting out of it? Are we in diminishing returns or not when you put that into it? So if it's from a cost benefit point of view, you know, it's nothing. You know, it costs very little. Don't worry about it. You know, it'll add a little efficiency. It might not be a lot of efficiency, but who cares? The cost to do it is negligible. In that case, fine, right? But
Yeah.
Otherwise, what I've seen is from previous products like that is an unconvincing benefit in their in the hype. You know, often they're compared to, you know, potentially poor systems, especially systems with poly B, for example.
Yeah, systems. So Fortis and Enercan are saying they're between 5 and 15% improvement, and the cost is negligible, and you get a rebate on commercial and retrofits. So
okay, then
yeah,
it's a no-brainer in that case.
Yeah, and it actually increases the surface conductivity of the pipe and the water. So that's what it's doing.
Yeah, in residential, there's not a lot of, you know, you're not going to squeeze too much out of it. You know, remember, we're supplying temperatures that are maxing out around 110 degrees, 115, maybe 120 in the coldest days, right? And we're conducting that into a lightweight concrete that's usually below a finished floor of some sort, you know? So by the time you calculate in that extra benefit of conductivity, you know, it's not as dramatic as a large load, a commercial building, where the surface area is quite a bit more. But if the cost, especially if there's a rebate, if the upfront cost is negligible, then I don't see the harm in it.
Great, thank you. Kirsten, I saw you waved in the chat. I don't know if that's you putting your hand up to ask a question. Go ahead and unmute yourself.
No, I wasn't. I was actually clapping about the suggestion of having them checked by cities, because I think that's actually having the systems checked. Because as a designer, there's so much, you know, we're making our buildings so much more, we're sealing the buildings so much more, that I think having an outside municipality checking the quality sounds brilliant. So I was just clapping for Rob, saying good suggestion.
Perfect. Jeanette, I see you have your hand up there though. Do you want to unmute yourself?
Sure. I'm actually wondering about Ben's question that he said not to worry about asking. I'm kind of interested in whether there are any initiatives down the pipe in Canada to encourage contractor best practices, ways of identifying for homeowners, which contractors are employing some of these best practices?
That's a really good question. So if we break it down to new construction versus um,
Retrofit.
retrofits,
Yeah.
we have in BC the home Performance Stakeholder Council, which is doing a pretty good job in getting standards of practice verification, but more than anything else, vetting the contractors in the first place and then following up. So on the retrofit side, they're a good resource for that, and they're making a dent. It's a work in progress, of course. We are trying to correct the course of a ship that's been going on for decades in one direction. It's a cultural shift, so it's slow and sloppy, but it's happening. So on the retrofit side, we have that. In new construction, we have been aware of and involved with a lot of initiatives over the last few years. So we just recently completed a CSA standard for mechanicals for builders, and that's being rolled out around. It's actually national, but we're starting to roll that out around BC. We have in that CSA document, stakeholders involved in producing that document were pretty substantial. So, for example, Enercan, utilities, industry organizations. There was a whole bunch of stakeholders in the industry that were part of the process of getting that done. So it's a set of standards that the industry generally agrees on. So that is a big deal to get that over with. And now we're talking to building officials on a regular basis, and we're not the only ones. It's happening on many fronts. So yeah, there is in process right now a trend toward adopting those standards of practice and adapting municipalities to discover what resources are needed, what tools are needed, and how to get those resources and tools to the municipalities with jurisdictions so that they can verify this. And ultimately what will happen is once it becomes required for an installation permit, for example, or a business license and that kind of stuff, then the contractors will adapt. They won't until they have to, right? And they won't have to until an authority, unless there is a requirement for a practice, right? Because after all, we've had decades of opportunity for contractors to up their game, and they haven't. Well, not all of them. There's been, luckily there's a bunch out there that are top of their game and know what they're doing, but they're the standouts. So we have to impose standards because the part 9 world, we haven't just adopted them unless there's been a regulation to make us adopt them.
Yeah, the only thing I was going to add on that question is I think that you'll see the first transition to more uniformity is around the requirement for load calculations, because a lot of folks don't know that the requirement for a CSA compliant load calculation has been in the building code forever, but it hasn't been enforced. And so now you're seeing, as performance-based codes and step code and zero carbon step code and us being the petri dish in BC for these things, the compliance and verification practices need to evolve as well. And Rob had a really good slide there showing the process for proper systems design, selection, installation. And if you get the load calculation wrong, all the other dominoes fall down incorrectly. So that'll be the starting point, I would assume, where we get more standardization across AHJs around requirements.
Great, thanks.
Great. Thanks, Jeanette. I was curious too, wanted to hop back to that question. And for those of you who do want to learn more about F280 load calculations, that is the topic of our next webinar too, just kind of looking at how to verify those F280 12 load calculations. We've had a couple more questions come through. Casper asked a question. He just said, he's an energy advisor, having had a system put in last winter and having not received a commission report / the recommended documents, do you say I should pursue the installer to provide the documents, or at least ensure that it was done? If I'm with a homeowner who had a system put in and similarly hasn't received proper documentation, should they push to receive it?
Absolutely. I think you're entitled to it. You paid for it. You know, you should expect it now. It becomes a little bit different, of course, if it's after the fact. Ideally, it's before the fact. I'm going to give you the contract, but you know, I want to see load calculations, all the commissioning reports and all that. Are you okay with it? And you know, if there's an agreement, you go forward. If not, you find somebody else. But after the fact, it's a little harder. But I think it wouldn't hurt to ask. I would, for sure, because I don't want to paint the picture of all contractors being, you know, I don't want to put them all in a bad light. A lot of them want to do the best they can, but they feel they're in a competitive environment where they don't have the ability to take on these extra tasks. Otherwise, they'll lose the job and so on. And you might find that your contractor is willing to do that. You know, it doesn't hurt to ask. I think the majority of mechanical contractors that I've met, you know, they're decent people. You know, they do want to do good work, right? And you know, all it might take is a little nudge for them to do it. Who knows? You'll never know unless you ask, and I think it's worth asking.
Great, thank you. All right, Billy has a question about calculating heating and cooling loads. How much does occupant load impact that calculation?
It's a good question. If you're using F28012, there is a BTU per individual. Almost half is on the cooling side is latent, the other is sensible. So the latent refers to the heat trapped in humidity. We all create it. It's also an assumption based on the fact that per occupant, there'll be so many lights, you know, cooking and appliances and all that. It affects the cooling load significantly. It's not the highest. The biggest impact is the glazing, of course. Then there's the heat gain from the assemblies. Usually the occupant load is third in that hierarchy of what's causing the heat in the house. Third, sometimes second, you know. So it impacts the cooling load quite a bit. It has hardly any impact at all on the heating load. It doesn't affect it much. It has a small impact, not much at all.
Great, and yeah, why Billy's asking this question is because he's trying to size a heat pump for 1,800 square foot community hall where the occupancy varies from a few people to 175 or more. So
Right,
should the system be designed for maximum occupant load or somewhere in between?
That is a really good question. So from a technical point of view, from an engineering best practices point of view, you're supposed to design to the peak load condition, right? But that's not always what whoever's paying the bill wants. They might say, yeah, we'll have 100 people for a couple hours once a year. We don't want a system for that. Well, you know, so if you're not designing for the peak load, what you have to really do is find a sweet spot that's the majority of the load, majority of the time. That's the most common condition that you're going to be dealing with, right? And you really need the feedback from whoever owns the building to get that and agree on that. And then what you need to do is when that peak condition occurs is add extra ventilation, because a lot of that peak load will be, you know, up to almost 50% in some cases, depending, of the that peak load will be latent. That'll be the the heat trapped in the molecules of moisture and humidity of the air. And if you can get rid of that, you can dry the air up by exhaust, by ventilation, then you can really mitigate the comfort level when that peak load condition exists.
Wonderful, thanks. All right, Billy, let us know if you have a follow-up question there. Oh, perfect. I was just going to ask any more questions. Todd just snuck one in. As a building official, we have just started to require permits and CSA F280 load calculations for heat pump installs. We are getting pushback from contractors not wanting to provide the F280 calculations, even though it is in the building code. So more of a comment than a question there.
Yeah. Yeah, it's I see it all over the place, you know, the pushback. I think the good news is when everybody in that jurisdiction has to provide the loads, then it's not a competition issue. You know, a lot of places, you're the one providing the load calculations, nobody else is, then you're less competitive. And unless you can figure out how to sell that as an added value, which you should be able to do in most cases. We've always been able to do that. But if you're in a jurisdiction and everybody around you has to do the same thing, then it's a non-issue. And yeah, of course, pushback, sure, you know, we don't want to do it. We never had to do it. I can understand that. You know, suddenly you're adding what looks like bureaucracy on the process. I say, so what, really, honestly? You know, if we had, I got to tell you, when I started in the 70s, there was a lot of initiatives because there was an energy crisis going on to get off of oil, for example, and all the guys in the oil, in the business of doing servicing and so on, a lot of their business was oil furnaces, right? And they screamed, you know, about intervention and so on, and didn't like it. When we got from plain Jane pilot lit furnaces to mid efficients, everybody screamed. When we went from mid efficients to condensing furnaces, everybody screamed. It doesn't matter what happens. There is a lot of knuckle draggers out there that'll scream everything we do. We'd still be living in caves if we listened to all that screaming. We got to move on, right? And I, you know, I understand and have empathy for the pushback. I understand it, but I don't have sympathy. You know, it's just like we need to move on. We need to make this stuff happen.
Perfect. Some more quotable content from Rob Pope there. Thank you. All right, folks, I don't see any other questions in the chat. Just another comment from Sean, just agreeing with you, Rob, the building industry is so slow to change and grow. Thanks for your comment, Sean. And yeah, just want to take the time for all of you HVAC contractors who are on the call here today and who are working towards learning with us. We do appreciate you and all the hard work that you do. Yeah. And if there are not any other questions that come through, we will wrap up here. We appreciate you folks. Oh, okay, perfect, Casper. Could an HVAC contractor outsource the load calculations then?
Sure. Yeah. Yeah. I think we'll start to see is there'll people who'll make it their business just to do load calculations when it becomes required in jurisdictions and enforced, right? And you'll probably get them done, you know, relatively inexpensively. And the only thing is, like right now, you can in a lot of places go to your suppliers and they'll do load calculations. That's the only issue. When they do it as a lost leader, for example, you've really got to check the inputs. It's almost always wrong, or inaccurate. But if you have a company whose reputation depends on the accuracy of their load calculations, in which there will be, then yeah, you can outsource them for sure.
Great, yeah, and Billy just suggested maybe some energy advisors can offer that service now that the federal rebates are drying up.
Yeah,
and then
I've always been curious why EAs don't do it. If I was just strictly in the EA business, I would have taken that on. Like, there's actually EAs out there to do it already, and they're cleaning up. You know, so it is a great opportunity for EAs to take it on.
And yeah, big thanks to you, Rob, for the presentation, and thanks folks on the call for an engaging Q&A session. I really appreciate it, and enjoy the rest of your day.
Thanks, everybody. Thanks, Jenna. Thanks very much. Take care.